Hello students, I am ready with my next video again. This time again video on mathematics for class 10 SSLC in Karnataka state. This time our topic is problems based on theorems in class 10. We have already discussed basic proportionality theorem, that is Thales theorem, SSS criterion, areas of similar triangles, Pythagoras theorem. I have already explained their proofs, as well as in my last video I summarized all these four theorems and I also explained results based on these theorems. Using these theorems and the results based on these theorems, we have to solve problems. In examination, definitely one question for either 2 or 3 marks comes and that question may be on any theorem, related to any theorem. Now let's discuss. Here I am going to discuss some problems that came in previous year's board exams. Here is a question. We have got a question here. It says triangle ABC is similar to triangle DEF. Triangle DEF. ABC is similar to DEF and their areas are given. Area of triangle ABC is 64 square centimeter. Area of triangle DEF is 100 square centimeter. Area, as you know, this inside space occupied by the triangle, that inside space is called area. This is space occupied by this triangle, and these two triangles are similar. That means their corresponding angles are equal and their corresponding sides are in the same ratio, right? Angle A will be equal to D, angle B is equal to E, and angle C is equal to angle F. Corresponding angles are equal because they are similar triangles. Their size may be different, but angles will be equal. We can apply SSS criterion. We can also apply areas of similar triangles theorem. Now, since areas are given and side EF is given. EF side is given. EF is 12. It is given 12 centimeter. EF is 12 centimeter. That is given, right? Area of length of EF is 12, and they are asking us to find BC. They are asking us to find the length BC. We have to find length BC. If you observe carefully, EF and BC are corresponding sides. EF and BC are corresponding sides. Why? Because E is equal to B, F is equal to C. Angles are equal. So EF will be corresponding to BC. Now we can solve this using areas of similar triangles theorem. It says, according to areas of similar triangles theorem, the ratio of areas of similar triangles is equal to square of ratio of their corresponding sides. It means if these two triangles are similar, then area of triangle ABC divided by area of triangle DEF, area of triangle ABC divided by area of triangle DEF, area of ABC divided by area of DEF will be equal to square of ratio of corresponding sides. Corresponding sides means we can take AB and DE. AB and DE are corresponding sides, or we can also take AC and DF, because AC and DF are corresponding sides, or we can also take BC and EF. We can also take BC and EF because BC and EF are corresponding sides. Now here, according to our question, if you observe carefully, area of triangle ABC is given, area of triangle ABC divided by area of triangle DEF, which is also given, will be equal to, I write here BC divided by EF whole square. This is the theorem, areas of similar triangles. According to areas of similar triangles, ratio of areas of similar triangles is equal to square of ratio of corresponding sides. This is the theorem we have already proved. Using that theorem we are solving the problem, right? Now area of triangle ABC that is given, it's 64 divided by area of triangle DEF. Area of triangle DEF is 100, that is also given, is equal to BC. Do we know BC? No, we do not know, we have to find. We have to find BC. So BC is kept as it is. EF, do we know EF? Yes, we know EF is given, that is 12 whole square. Right? Now, out of four quantities, 1, 2, 3, 4, out of 4 quantities, 3 are given, 1 we have to find. That's very easy. It is very simple, right? So we substituted the values, and now taking square root on both sides. You know that if we remove this square, this will go under the square root. But it is the same as taking square root on both sides. So what will happen? This square and root will get cancelled. Then what is left? BC divided by 12 will be equal to, BC divided by 12 is equal to square root of 64. What is the square root of 64? That is 8. What is the square root of 100? That is 10. We know that 100 is the square of 10 and 64 is the square of 8. So BC divided by 12 is equal to 8 divided by 100. Now cross multiply. Take this 12 here. So it will become BC is equal to 8 into 12 divided by 10. BC is equal to, this 12 will go there and multiply, cross multiply, right? So it is in denominator here. Of course, it will go to the numerator. If it is in numerator, it will go to denominator, right? So now simplify this. It's very simple. 2 times 5, 2 5 is 10, 2 6 is 12, right? Now BC is equal to 8 6 is 48 divided by 5, or that will be equal to 48 divided by 5. 48 divided by 5. 5 9s are 45. 5 9s are 45. 3 are left. Put point and take 0 with 3. That will be 30. 5 6 is 30. That is 9.6 centimeter. Why centimeter? Unit centimeter? Because area is given in centimeter square. And also the length of EF is given in centimeter. So the length of BC will also be in centimeter. Writing this unit is also important, right? So BC is equal to 9.6. Right? So we got this answer, 9.6 centimeter. This is how we used theorem areas of similar triangles to solve one problem, right? We'll solve next problem now. Now next problem. Our next problem is based on another theorem. The question is, a triangle is given, triangle ABC, and in triangle ABC, a line DE is drawn parallel to BC. DE is parallel to BC. Now what we have to do is, we have to find AC, the length of AC. We have to find the length of AC. AD is given, that is 2 units. Unit is not mentioned, centimeter or meter or inches, that is not mentioned. AD is 2 units. BD is 5 units. AE is given 4 units. They are asking us to find AC. This length we have to find. We have to find AC, right? Now if you remember, this is basic proportionality theorem. This question is related to Thales theorem. In Thales theorem, in a triangle, a line is drawn parallel to one side, then that side divides the other two sides in the same ratio, proportionally, right? So now that theorem will be applied here. According to basic proportionality theorem, if it is so, if this is the case, then the DE is parallel to BC. As I told you, forget the parallel lines. Forget the parallel lines. Other two sides, AB and AC, will get divided into equal ratio, right? So that is, we can write AD divided by AD part divided by DB is equal to AE divided by EC. We can write this. This is one possible result. It is true. Or we can also write, as I told you, you can take the full length also, AB divided by this full length AB. With that you can take the upper part, that is AD, will be equal to, here you are taking AB full length, so here you have to take AC divided by AD. You have taken upper part here, this side you have taken AD, so this side you have to take AE, the upper part. Once again, you can write one more, AB divided by AB full length divided by, you can use the lower part also, that is BD will be equal to, here you have taken AD, so here you have to take AC full length divided by BD, you have taken lower part, here you have to take lower part, that is EC. This is also a true result. Now we have to guess which result can be used here. If you observe carefully, here part by part, we can find this part using this result and later add 4 and this part, you will get AC. Or you can use this result, AB divided by AD is equal to AC. AB is full length, so AC will be full length. AD is upper part here, so you have to take the upper part here, AE, right? Now AB, what is AB? Do we know the length AB? Yes, we know. 2 plus 5, that will be 7, divided by AD is 2, that will be equal to AC. We don't know, we have to find AC, we have to calculate the length of, we have to find the length of AC, divided by AE. Do we know AE? Yes, we know, it's 4. Now, out of 4 quantities again, out of 4 quantities, 3 are given, the remaining we can easily find. So cross multiply, so it becomes 7 into 4 divided by 2 is equal to AC. Take 4 here, it will cross multiply, it will multiply with 7, right? 7 into 4, you know this is basic thing. Then this will get cancelled, so AC is equal to 7 times 2, 7 2s are 14 units. Why I am writing units? Because unit is not mentioned here, so that may be any unit. So 14 units. This is one more problem, very easy, came for 2 marks in exam, based on Thales theorem, that is basic proportionality theorem. We will solve one more problem now, another problem. Now let's move on to the next question. Our next question is, triangle ABC is a right angled triangle. Why? Because at B we have right angle 90 degrees, right? So triangle ABC is a right triangle. Now in this triangle, so we can apply Pythagoras Theorem here because it is a right triangle. But one more thing is there. From right angle vertex, a perpendicular is drawn. A perpendicular line is drawn on AC, and the length of that perpendicular line 8 units is given. It's given 8 units. BD is 8 and AD is also given. We have to find DC. They are asking us to find the length of DC. Now this we have already seen when I summarized the theorems, Pythagoras theorem. I explained this case also. According to Pythagoras theorem, in triangle ABC, square on the hypotenuse will be equal to AC is hypotenuse, so AC square is equal to AB square plus BC square. AB square plus BC square. That is Pythagoras theorem in triangle ABC, because at B we have 90 degrees. This is Pythagoras theorem. But we cannot use this result here. Of course, AB is not given, BC is not given, and AC we do not have to find. We have to find a part of AC. Now what to do? We will use the other results which I explained. Other results were also explained in that video, previous video, right? What is that? Other results are, I showed you. What about the square of AB? What about the square of BC? What about the square of BD? Do you remember? I explained AB square will be equal to, in that case you have to take the hypotenuse AC in AC there are two parts. AD and DC. Which part is attached to AB? Which out of AD and DC, these two, which is attached to AB? AD is attached to AB, so AD will come here. Also BC square will be equal to, you have to take the full length of AC into out of these two parts, which part is attached to BC? DC is attached to BC, so DC will come here. And one more we can write result, BD square. One more result is possible, BD square. What about the square of this line? BD square will be equal to, I told you, in this case, the line which is passing through right angle vertex and perpendicular to hypotenuse. For that case, we will not take full length AC, just like here we have taken. We will take part into part. That will be AD into DC. AD into DC. BD square will be AD into DC. Right. Now these are four results which we have already discussed. These are the results which we have already discussed in previous video. Now to find DC, which result do you think will be suitable here? Of course, this one. Why? Because BD is given, AD is also given. We have to find DC. So out of 3, 2 are given, 1 we have to find. That will be very easy. In other results, 2 will be unknown. It will be difficult. We cannot. So here now, BD square is equal to AD into DC. Right? So now BD square, 8 square, because BD is 8 square is equal to AD is 4 into DC. DC we don't know. We have to find DC. We have to find the length. Right? Now 8 square is 64 is equal to 4 into DC. Take 4 here. It will be same as dividing both sides by 4, right? So it will be 64 divided by 4 is equal to DC. Right? Now DC will be equal to, if you divide 64 by 4, that will be 16. Right? That will be 16. So that is 16. 16 units. 16 units is the length of DC. We got it. We used here result based on Pythagoras theorem. So this is another question we solved here, very important. This type of one question, the questions which I am explaining here, this type of one question definitely comes in exam. So practice these questions, and similar type of questions are there in your reader also. Solve those problems. Again, next problem is also related to any one theorem which I explained already. And the question is, triangle ABC is given. In this triangle ABC, XY is parallel to BC. XY is parallel to BC. And XY, the length of XY is half of BC. This is also given. XY length is half, 1 by 2, half of BC, half of BC. That is also given. And area of triangle AXY, this AXY, this area is given. AXY, area of this triangle is given, which is 10 square centimeter. This area, AXY, area of this small triangle, area of this small triangle, AXY is 10 square centimeter. And they are asking us to find, area of trapezium XYCB. If you observe carefully, there is a trapezium XYBC. This area we have to find. This area we have to find. We have to find this area. This area we have to find. XYCB is a trapezium. Trapezium is a four-sided figure. Trapezium is a four-sided figure. This is four-sided. XY, YC, CB and BX. Trapezium is a four-sided figure. In a trapezium, two sides are parallel. You can see XY is parallel to BC. XY is parallel to BC. Two are parallel and the other two are non-parallel. Other two are non-parallel. So here BX and CY are non-parallel because if you extend they will meet. But if you extend XY and BC, if you extend they will never meet. So they are parallel. These two are parallel. These two are non-parallel. In a trapezium, two sides are parallel, two sides are compulsorily non-parallel. So total four sides are there. So it's a quadrilateral, right? We have to find this area. We have to find the area of this. We have to find this area. This area we have to find. Area of trapezium XYCB. We have to find XYCB. This we have to find. Okay. Now, first of all, this question is related to area. Area is given, right? Area. So areas of similar triangles, that theorem will be useful here. Areas of similar triangles. Now first of all we have to prove that the two triangles which we see here are similar. Which are the two triangles you see here? We have a triangle AXY. If you observe carefully, we have a triangle AXY, right? This is small triangle which is 10, and we have a triangle ABC. ABC is the big triangle, the given triangle, right? Okay. Now, if you observe carefully, angle A here is common. A is present in AXY, and angle A is also present in BAC, triangle ABC, right? It's a common angle. Angle A is common. It is present in both triangles, small as well as big. So one angle is equal. Angle A is equal to angle A, right? That angle at B will be equal to angle at X. Now question comes why? Because these two are parallel lines and this is a transversal. When two lines are parallel, and a transversal cuts them, this is the transversal. AB is the transversal cutting XY and BC. So what happens? Corresponding angles are equal. So these two are corresponding angles. They are equal. Angle X is equal to angle B. Reason? They are corresponding angles. If two angles are equal, A is equal to A, common, XY is equal to. So therefore now Y will be equal to C. Angle Y, remaining angle will be equal to C. Because angle Y will be equal to angle C. Because remaining angle in two triangles, if two angles are equal, then third will be definitely equal. Right? So they are equal. Remaining angles. They are equal. Right? Now, these two triangles these two triangles here, x is equal to b and y is equal to c. We proved that these two triangles are equiangular. Their corresponding angles are equal. If their corresponding angles are equal, then triangle AXY must be similar to triangle ABC. Reason SS criterion. According to SSS criterion, in two triangles, if their corresponding angles are equal, then their corresponding sides are in the same ratio and the two triangles are similar. So these two triangles are similar. The small one AXY and the big one ABC are similar now. If they are similar, we can apply theorem areas of similar triangles. So area of triangle AXY divided by area of triangle ABC must be equal to square of corresponding sides. Which corresponding sides should we take? We'll take XY and BC. XY and BC are corresponding sides. So here I am taking XY. So here I will take BC. Right. Now, area of triangle AXY. Do we know area of triangle AXY? Yes, we know it is 10 divided by area of triangle ABC. We don't know. Is equal to, now here XY. Can we write XY as half BC? XY can be written as half BC. So I can replace XY equal to half BC divided by this BC. I replace XY by half BC. Why? Because in question it is already given XY is equal to half of BC. Then this square will remain as it is, right? This BC will get cancelled. So area 10 divided by area of triangle ABC will be equal to 1 by 2 square. 1 by 2 square is 1 by 4. Now cross multiply. Take this 4 here, area of triangle ABC there. So 4 will come here and multiply with 10, and 1 into area of ABC will be area of triangle ABC. This will multiply with 1, right? 1 into anything is same, right? Therefore, area of triangle ABC is equal to 40 units, 40 square centimeter. We got area of triangle ABC. We got this all area, this all, including 10 is 40. In this 40, this 10 is also included. Because 40 is area of triangle ABC, all ABC. But we have to find area of only this. This one we have to find. Now we know area of this triangle ABC, complete triangle, is 40, and area of small is 10. This small triangle is 10. Then what will be the area of this part? This full area is 40. This much is 10. Area of triangle ABC is 40. Area of triangle ABC is 40. ABC all 40. And the smaller one, this upper part, this much is 10. What will be this much? 40 minus 10. Remove this from all. Remove this part. What will remain? This will remain, right? So area of trapezium XYCB will be equal to 40 area of triangle ABC minus 10 area of triangle AXY, right? That will be equal to 30 square centimeter. So 30 square centimeter is the area of trapezium XYCB. We got it. This is the question that came in exam, and we used theorem here. We used theorem. I hope you all understand this. I want you to practice these questions well, because one question definitely comes in exam. Thank you.